Hello, hello. Let me know if you can hear me. Alright, we'll just give it, I don't know, 1 minute for some people to gather. Everybody relaxed, chilled. Sunday evening for me. I don't know what time it is for you. Phone Reparo, Nico, is from my country, so we're sharing the same time. Yeah, I'm streaming from Linux, so I hope everything is gonna be okay. I don't know if I streamed lately here. So we have iPhone 16 Pro that has some charging issues, but the problem with it, what I didn't like, is that the display, sorry, this is not the display, the display is heavily cracked. Otherwise it works. So the phone, I can start the phone with a power supply, the display works and touch works, yeah? But this is all we know. But before we start, I wanna mention again about the USB-C, and I wanna take advantage of it, because I just want us to be sure we understand how it's working, right? So basically, we have the USB-C connector, right? So this is the connector, and on this end, if we connect, for example, I'm going to connect a terminal like this one. So this has nothing, it just has some points here that we can actually probe and test, right? This is not doing anything, so we can see here, we see 0.3 volts, but this is because of my USB meter. So basically we will have 0 here. So if we have a look, let me see if I can maybe zoom it in a bit. Yeah, we have a lot of points here. When we speak about power delivery, we are interested only in the ground. We are interested in V-bus, which is the line that provides the voltage, and we are interested in the CC lines, right? So basically we have the connector like this, yeah, and the connector will have a ground, yeah, a V-bus, which is the plus, correct? And then we're gonna have two CC lines. Yeah, that's because we can plug in the connector like this or like this. It's called CC1 and CC2. Good, so this is all we know until now about the USB-C connector. And this connector is already connected to the power supply. To the, actually it's a laptop charger that I have connected here. So if I put the multimeter in voltage mode, right, we see the volts up there, and I'm gonna connect the negative ground to ground, and the positive I'm gonna connect it to V-bus, which is this line here, and we have 0.3 volts because of the INA sensor and the microcontroller that I use to display actually here. Yeah, but this is irrelevant, so 0.3 is not is nothing, right? Okay, so let me see what you wrote until now. Come on, let's repair. I'm doing an iPhone 13 that is not charging. Yeah, well, apply 1.5 volt to CC line. It will trigger the voltage. That is wrong. What do you mean, Nico? It will trigger a voltage. So it will not trigger any voltage. Yeah, so now we have 0 volts. So let's understand. See, you need to learn something. Let's understand how this works. From here, let's say this is the charging thingy, and here we have the phone board, right? VBus will be connected to VBus, CC1 to CC1, CC2 to CC2, and ground, right? And in the phone, we have the ACE, right? We have the ACE chip. CC1 and CC2 will go into ACE. VBus will actually go through a circuit called RVP. RVP, it's a reverse voltage protection. This is just a simple, it's a P-channel MOSFET and a diode, and that's it, right? And this goes into the ACE, right? And also the ground will go to the USB power delivery controller. From here, the next circuit in the charging step is the charging IC. Charging IC, right? Charging IC gets main, yeah, because this eventually will produce a main through the BPIC. So we have the BPIC chip, which will produce the main, and then the main will power the charging IC. Then we're gonna have some coils, and this eventually will go into the battery, right? But the battery has some clock and data that will communicate with the charging IC, and the clock goes to usually to the PMIC of the phone, which also communicates with the charging IC. And in the charging circuit, what we are interested in is this line that eventually will tell the charging IC that we have a charger valid. Charger valid. Yeah. The moment ACE, the PD controller, says, okay, I am connected to a good charger, it will push a 3v3 volt, yeah, which is gonna be up all the time. If it goes down, then the charging IC will stop the charging. Now let's focus on what happens with the EASE, right? Because this is the USB controller and we are mostly interested in. Let's assume the phone has no battery. See, the battery is disconnected in this case. What's happening with this circuit when we want to connect the power? Because you saw we measured here and we have no voltage out, right? So basically this circuit will require some power to be able to work, right? And that power will come from this line, from the RVP line. But for this line to be enabled from the charger, we need to pull down those CC1 or CC2 lines, right? So let me show you basically what's going on. In the charger, we already have a pull-up resistor, and here we're gonna have to apply a pull-down, which is actually not going to pull it all the way down, but it's gonna pull it just a tiny bit. So let me bring back the oscilloscope on the screen. Yeah, see there we have two lines. So the blue one is the VBus, which is 0 now. So VBus is 0, and the yellow one is the CC line, which is 4.3 volt. Yeah, because it is a bit down, it's not quite 5. Now what we need is to pull down the CC1 or CC2 line. So to pull it down, we need to connect basically a resistor to ground. Yeah, usually this is about a 5.5k, 5.6k resistor, whatever. So look what happens if I have here a resistor and I'm gonna put it to ground, the CC2 line, for example. Yeah, look on the oscilloscope what happens. You see the yellow line comes a bit down. Yeah, I connect it, it's down. And you also see that it tries to communicate. So now it stopped communicating. You saw those lines that go down. That's the charger asking, hey, is there anyone there? Yeah. Hey, is there anyone there? What do you want? Do you want 5 volt? Do you want 9 volt? Do you want 15? Do you want 20? How many amps? I have, for example, I'm a 45 watt charger. This is what I can provide, right? And also you notice when I'm connecting the resistor, the blue line goes up. So blue line, that's our V-bus, goes to 5 volt. And you also see here, right? So this is not, we don't need to put voltage into the CC line. We actually need to put a resistor to bring it down, right? So basically when we put the resistor on, then we have 5 volt going in our ACE chip, yeah? And that moment the ACE chip is actually powered on. When it's powered on, it will gonna have 3v3 LDO, right? That's gonna be produced by the ACE because it needs that power to bring up some lines. For example, it needs it for the charger valid communication. It also needs it for the flash ROM, right? So it has a flash that is being powered with this 3v3 LDO. So this is quite simple. Good. Now look what happens if I connect, for example, my phone. Yeah, I'm gonna connect my phone. You're gonna see that this will communicate more. So look there and see there was already communication, and the blue line, which is the V-bus, jumped to 9 volt, I think it is now, right? We have the DVM. So see, for example, right here, do you see my mouse? Yeah. So see here where it says DVM, this is the value of the CC line. The moment I connect it to the phone, it will go down to 1.6 volt, right? And between the 1.6 and the 0 will be the communication step. Yeah, I'm removing it. It goes back to 3 volt. If I set the DVM to show us the second channel, which is the V-bus, right? Now it's 0. Yeah, it's 200 millivolts. We can ignore that. If I connect it to my phone, yeah, it goes to 9 volt because the phone, you saw it communicated and it said, okay, give me that. Good. So are we all clear with it? Let me see the chat because I can't really read it, but very good on the OBS screen. Hey, Serge. Hi, I recover data. My God, there are some names that I really can't read. I'm sorry. Pico, hello, hello. Big fan from the Philippines. Yeah, thank you very much for joining. Well, so this is the basics, right? So when we look on the phone, we are interested if we have CC lines, if the RVP will start, if V-bus E85, which is this one. So this is the V-bus E85. I think this is the correct name. And here is V-bus E85 RVP, which is powering the ACE. So first we need to make sure that the internal resistance, so this one here, which is inside the controller, works, and it's turning on our supply to 5 volt at least, meaning that it's gonna power the ACE, right? Then we need to check if the ACE is producing that 3v3 LDO. If we have all those, we can think that the ACE chip is actually fine. We can check also if it provides a charger valid. We already know that the touch works, so that's sometimes the touch doesn't work if the ACE has a problem, but I tell you for sure that in this phone the touch works, right? Then we can also check what's the boot behavior. So the first boot should be like 70, 80, 100, 120 milliamps and then go up. If the first boot is above 100 milliamps, I tend to believe that we might have a problem with the ACE power delivery controller, but it's not always the case, right? So let's see what happens with this phone if we plug it in. So I plugged it in. Charger communicates. See, it's trying to communicate, but nothing gets back. Also, we have 5 volt, right? We can see that the voltage is 5. We can see it on the oscilloscope too. So I'm gonna disconnect it. See the V-bus goes to 0, the blue line, and the yellow line, which is the CC line, goes up, right? Coming back down to 1.6, and V-bus goes to 5 volt. Now I know for sure that I do have the V-bus E85, right? So that voltage we have for sure. I am not sure if we have this one. There's almost no reason not to have it, right? Almost no reason not to have that. Good. So I said the second test we'll do. We already know that it has touch, right? I'm gonna connect the power supply to the phone. Yeah, power supply is connected. Let me bring it on the screen because for the moment we see the USB one. I'm not sure which port is this one. Is it this one? Yes, it is. See, and I turned on the power supply. Now we see here, we see 4.1 volt instead of the battery, right? So I said I'm gonna press the power button, but briefly, just press it like this. And what was that? It was above 200 milliamps, right? Let's do it again. Yeah, 200, and then goes a bit down. That's not, no bueno. 200 is too big of a current, right? Good. I don't even care about actually powering on the phone. I'm gonna turn off the supply for the moment, and let's remove the board and see what our problem could be further. Yeah, unfortunately this is gonna take a bit because I didn't think in advance to actually have this removed. I've removed only the screen and I've removed only the back plate. Yeah, but we're gonna do it fast, hopefully. Hopefully we can move fast. Don't do what I do using these metal tweezers unless you're really used with this. Otherwise you can actually damage stuff around there. I need a few screwdrivers, so I think this will do it. I need a magnet. Everybody okay? All good? Did you have a good weekend? Yeah, unfortunately we have to also remove this kind of a speaker assembly, whatever. It's quite big, and this board has here something that is behind that speaker assembly, and it's screwed in. Some people force that, I don't know why, and they break that part. I mean, it's like you have to undo here like 5 more screws and you're done. You don't even have to actually remove this one, just lift it up a bit, see, like that. And now I think we can actually remove the board. I hope I actually removed all the... Did I miss anything? No. Okay. Hey bro. Okay, so let's go under the microscope and let's go right here. Yeah, where we have, I think we can actually close the oscilloscope for now. We don't need those. Yeah, because I know for sure I'm gonna apply heat. I'm gonna actually remove all these and we'll put them back after. All the plastic thingies. Good. Okay, so now we need to remove this one. I'm gonna actually cut it. So I'm gonna apply a cut here. I don't want to go too deep. I'm just trying to make a straight line for my OCD, you know. It doesn't need to be straight or whatever. Good. And now I'm gonna use, you know what happened? So yesterday or the day before, I don't know, I broke my my pliers. How do you call that thing that cuts cuts metal, you know? I'm not sure. So English is not my native language and I'm having trouble with words sometimes. The cutter, you know, it's like, I don't know, like some pliers. So I hope I'm not gonna break anything. I just need to have to be attentive just a bit. Here is simple because I can actually use the SIM card thingy here to actually have a sort of a leverage. And my knife broke, but I think we can do it like this, no worries. Okay, now I need to figure out how we can leave this because, as I said, my cutting pliers broke. Watching your videos helps me a lot, especially on the 16 Pro Max charging. Yeah, side cutters pliers, yes, correct, that's the one. Nigeria fan checking in, great video, thank you very much. Yeah, I know these 16s are more and more common now, and they obviously have a problem with the charging circuit. Yeah, so I'm trying to actually leave this, and that is good. This is perfect. Okay, so now let's get a board view. As I said, I am in Linux now, and the only Linux available board view software is Paul Daniels. software. So let me open FlexBV. Okay, and I'm gonna open a 16 Pro Max. Let's see if we can see the desktop. Yeah, maybe like this. Good, rotate right. Let's make this a bit bigger. Okay, so we're interested here. So we have 3 chips here. This is the ACE, yeah, controller, the USB power delivery controller. This is the charging IC, and this is the BPIC. So that's the chip that creates the main from the battery power. Good. Let's put here also microscope cap. I think it's gonna be easier. So let me copy this, paste it here, and maybe make it a little bit smaller like this. Good, and we also need a multimeter. Yeah, we have the multimeter right there. Good, let's put the multimeter in diode mode because this is what we care now. And let's look. So the first thing I'm interested in is the RVP thingy. So for the RVP, I need to go back on the other side. Now this may look a bit funky. This is the VBus E85. I'm gonna turn back here, right? So VBus E85 goes to this MOSFET, yeah? This is the RVP circuit. It's very simple. It doesn't work to... Basically, it allows for the voltage to pass through it and to the USB power delivery IC, and it doesn't allow it to go back, right? So this is the RVP. This is the line that will power our chip, and let's see if we have any sort of weird short. So what we know now is that the phone consumes a bit more than it should, right? It goes to 200 milliamps on the first boot. So first of all, we can check here, right? We have a small resistor. That diode we cannot check because we can't reach the points. But here, if we check, so the E85 RVP is 0.6. So I know for sure that for that value we are fine. Then we can also check the see, we have 2 caps here. One is the 3V3S2. So the 3V3S2 line is produced by the PMIC. So that works when PMIC delivers it. We are not very interested in that one. We can also check it. So I think it was here. Yeah, it is 0.5. Yeah, but I'm mostly interested in this one, 3V3 LDO E85. Good. So if we look on the 3V3 LDO, is freaking shorted. Yeah. So obviously our chip is wrong. So the USB power delivery controller. It's interesting. You see, this is this is actually conductive. See, we have 7 kilo ohms. Good. So the E85 is shorted. And what can it be? It can be this chip, it can be this capacitor, and it can be the flash, the ROM that it uses, and there's a few smaller capacitors on this side and some resistors, but we don't really care about them. But this is obviously the problem is because of this USB PD controller. Okay, so we know that this PD controller is bad. Good. Now that's a problem. So the problem with this one is if we need to replace this one, we need also the ROM if we get it from a donor board, yeah? And I'm always getting them from a donor board because a donor board costs maybe less or almost the same as the chip costs on Mobile Centrics, right? So I prefer a donor board because I have way more spare parts left. Good. So let me have a look on the chat. Okay, so nothing more on the chat. We have 26 viewers. That's great. Good. So now we know that we need to replace this one, and we also need the ROM contents. But the problem is that the ROM is on the other side of the board. So let me show you. Where is it? I think I have a split board already. I had one here. Yeah, so there's one. This is one where I removed the CPU. But this is where our chip is, right? So this is the USB PD controller, and our ROM is on the other side. Well, was here because I've pulled it and read it. You know, I'm writing down the number of the boards because I'm saving that ROM. And when I'm gonna remove this one, I know that the ROM I already have saved, and we don't lose much time. We don't lose much. I don't lose much time reading it again or whatever. Good. So let's turn our attention to the charging IC. Yeah. So this is the VBus E85. I think we already checked it, right? And we said that it's actually fine. Yeah, it's open, so this should be open, should be 1.8 or actually open. It's OL. As you see, it doesn't display any value. Do we have something here? I'm just gonna measure this capacitor too, just to make sure we have no issues there. Good. I'm trying to exclude the charging IC, and we have an LDO right here, and this. So all these three we actually need to check. So this one is fine, the internal LDO is fine, and this one, which was it on the left, yeah, this one is also fine. Now I also know, well, I know the guy that gave me the phone, the service repair shop, said that this phone actually was charging wirelessly. Good. So now I think it's time to actually remove the chip and proceed in replacing it. So it is possible for this phone to actually have a single problem, and that would be the USB PD controller. I'm not sure I'm gonna use a bigger nozzle. I'm always a bit anxious removing these chips without actually splitting the boards, yeah? So I'm gonna need to pay a bit of attention here. I'm just heating up the board all around it. This is gonna take a lot of heat. Yeah, and now I'm gonna add some flux behind the chip. I don't want to add too much because it's only gonna create a mess that is gonna be harder to clean later. I need my bend tweezers. Now the problem with these phones is that everything is so tight here that it's extremely easy to bump parts. So I'm just gonna hold this board in the air, as you see, holding it by the chip, and the board will fall down when the chip is gonna be desoldered. Good. Chip is out, see, and we didn't move any parts around it. So this is gonna be an interesting one, because we also need to write that flash. I said that I'm not using actually new chips. Okay, I'm gonna add a bit of low melt. Good, and now I think we can actually wick it. So let's get a piece of wick. I'm gonna read the chat in a second. I'm just gonna take advantage of the fact that the board is actually warm, so I can wick it properly. Yeah. Otherwise it's gonna suck all the heat because the boards are not split, so boards are still sticking together. Yeah, so I'm just tweaking it a bit. Usually, in most of the cases, this is not the broken chip. The problem is actually with the charging IC, so with the chip that stands right next to it. It's quite rare when this also fails. It's more often they both fail together. So I hope it's gonna be just this one here. Yeah, good. Let me read the chat. I2C from programmer, so won't need to separate boards. Correct. So we're gonna use the programmer, so we don't have to separate the boards. Is it enough to run a firmware update on the phone after replacing S instead of replacing the ROM too? No, that will not work. The phone will remain in port DFU when you're gonna connect it to the computer. So that's you can't do it. If you use the ACE controller from a donor board, you always need the ROM. Yeah, if you don't use it from the donor board, then you actually don't have to actually rewrite the flash or whatever. The phone will just work if you buy the chip from Mobile Centrics. I heard that if you use ACE from donor board with updated iOS, you won't need to program the ROM. Haven't tried it. I haven't tried it either, so I always program the ROMs. It's not a big deal. So I'm gonna take this chip here. I hope it's fine. So I'm not sure what's its status and if it's good, but we're gonna figure it out. So first let's actually grab this one, because the ROM I already have it on the computer, so we don't have to connect twice the programmer to two different boards. So this will actually work a bit faster. Good. Chip is off. It worked faster because we don't have the other board, the top board sticking to it, so that's why it went out that fast. So let's reball this one. I need to turn my iron a bit down because when I wick I set it to 400 plus. There's something I don't like about this iron. Well, it's not this iron, it's this tip. So this is not an original tip. This knife tip is something that came with this FNIRC station and it's not great. On the other station I do have an original one which is way better. There's a huge difference if you buy the original chips, the original tips from JBC. And they are way better. Good, I'm gonna reball this one, but then we're gonna have to actually write the firmware before we put this back on the board, because if this is back, the CH341A will have a 3v3 shorted, because this chip, the internal LDO, will short any input voltage. Yeah, so when we program it, or read from the donor, this chip can't be on the board. Yeah, this is a must. Okay, let me find the stencil. iPhone 14. Let's see what we have here. $15, $16. 16 right here. Let me see, where is my... Yeah, there it is. I have some very old paste here. We're gonna use that one. When you will be sharing about radio frequency, so I'm gonna be sharing about radio frequency when I'm gonna have something relevant to share, because usually phones with radio frequency problems are coming in when they are broken, right? And I don't do broken phones. I don't do broken phones unless it's data recovery. I quit that because it's very difficult to actually provide warranty for those. The RFFE part on the iPhones is actually great. Starting model 11 onwards, because I don't know if you remember, on the model 11 they had that 3V15 VF something line that was being shorted out by a capacitor, and then you would either lose Wi-Fi or you lose baseband. Yeah, so that was something normal. There are a few 12s that also had issues with the baseband PMIC. Yeah, but in these later models there's actually no problems unless they are broken, and if they are broken I don't repair them. Yeah, I quit repairing broken phones. So when I'm gonna have something that is actually relevant and is not broken, but it has a problem on the RFFE side, I'm gonna get something. So I have a question in Romanian there from a colleague that is asking if there's any possibility for me to do mentorship or training sessions. For the moment there is none, because this is a hobby for me, and it's a side gig that I do, and my current job is actually keeping me extremely busy, and I really don't have time. But if I would ever lose my job, or I don't know, something would happen, I will definitely open a school shop, you know. It's gonna be a school shop, I know that for sure. So it's gonna be a shop, a repair shop, but it's gonna be a school in the same time, and I'm gonna be tutoring people that want to learn this while actually working in an environment like that. But for the moment I don't have really the time to do it. Physically the time is not enough. And also, if you're really interested in this, you could learn yourself. So I learned it myself. There was absolutely nobody teaching me nothing. So I watched a lot of YouTube, a lot of people repairing phones. Then I actually bought like 200 iCloud lock boards, and I started practicing on them. I started measuring, I started removing chips, removing CPUs, putting them back, see if they start, see what those chips do. Yeah, I spent some time, when COVID came, and I didn't have to go to the office anymore and I worked home. there was already a lot of time for me, extra time, you know, so the time that I will spend on going to the office, coming back, that's like 3 hours a day, right? Also in the office you have that time, so I work in IT. It's not like you work all the time non-stop, so there are that times when you actually don't have anything to do, right? But being in the office, there's nothing, you just sit and wait for the evening to come and to go home. There's really nothing more you do. But being home, when those dead times were available, I always switched to my bench and I would start tinkering. There's a piece of hair here. I would start tinkering on boards or watch YouTube or I don't know. Yeah, so COVID, from that perspective, COVID did great for me. And I've never returned back to the office. So since COVID, I'm only working from home. I disconnected so much, I don't like people anymore, I don't like office feeling, you know. Can I ever center this? Good. Okay, let's try to stick it back. Ah, no. Ooh. Jesus, I forgot. We need to write the BIOS. I'm such an idiot. Why didn't you say anything? Nobody's listening to me. Yeah, you're welcome. I'm on this path. It's a bit overwhelming, but it's also a lot of fun. It is. So this is, I always like to have a hobby, right? And when COVID came, I didn't start directly with electronics. I live somewhere near the woods, so my house is surrounded by woods, and I liked very much riding enduro bikes, right? And I had like 3 bikes, and I would always ride them whenever I had a chance. But the problem is that I kind of messed my back. I don't have a disc anymore, so 2 vertebrae are actually stuck together, and because of that I couldn't ride bikes anymore, so I turned into electronics and I started buying tools, micro-scope and stuff like that, right? But I always needed a hobby in my life. I'm preparing here to solder wires for the reader, right? So let's see. I'm using the CH341A. Yeah, we don't need this for the moment. So I'm using this programmer right here, which I already have wires sticking to it. Right, so it looks like this. It's CH341 black. And I have somewhere a document, let me find it. Okay, right here. So if we turn the desktop like this, do we see it? Yeah, like that. So here is the document that's telling us how to connect this one. Good. So okay, let's start the first one. This is gonna be a bit boring, but that's it. So this is ground. Good. Next, the second wire is the purple one. It comes here. Good. Third one is the orange. Comes here. Good. We need to connect 6 wires, right? We have plus, minus, and 3 for communication lines. This one is the red one. This comes for the plus LDO thingy. I need this because it needs to power the chip, the ROM chip. Good. Then the next one is the blue wire. Yeah, so blue comes here. And the last one will go right here. Good. So let's go back. I'm gonna connect this to the USB port. Okay, and we need a programmer, and I'm gonna use this one so you can understand what is going on. I'm gonna click detect and it doesn't detect my chip. What the fuck? Did I connect something wrong? Why isn't it working? Do I have 3 volts here? Let me... Yeah, at some point I was working on with this programmer or on something else. I hope I didn't ruin it. Yeah, we have 3.3. Okay, let me see if maybe I didn't connect something correctly. This is freaking annoying. I have a loose wire. Good. One wire got loose. So let me put it back and let's see if this was the problem or something was not properly connected. Okay, let's try again. Okay, connected. Programmer. Detect. Extraordinary. Missing chip. Okay, let me see with flash ROM. Can I do it with flash ROM? Okay, so this is a command, a bash executable. I need to remove this so you can see everything. So let's see, is it that? No, it doesn't work. Good. Okay, so let me have another look. Did I do anything wrong? So this one is the 3v3, but we knew there was 3v3. I'm gonna check it anyway. I'm gonna start with the first one. So first one should be ground, right? First one is ground. Cool. Second one. Second wire is the top one. So second wire, purple, is the top one. 1, 2, 1, 2. Pa-pam, pa-pam. Good. Third wire. Third wire is on top, so yeah, this is not good. So third wire is the orange, should be down. Oh no, it's good. It's bottom right. Orange, good. Then first one was green. That one comes up there. Good. And then we have this one. Second. It's blue. It should come down. Good. That's good. And the last one. The last one is the 3v3, right? Red one, yes. So why it's not working? Yeah, let me fire up the Windows machine. Maybe it's a bit picky. Let's see. It's gonna take a while for my laptop to boot. I don't have the jumper layout for 15 Pro Max, but it's not difficult to find it out, because it's yeah, you have the pins from here. So where is it? It's on the other side. It's like a regular BIOS chip. Freaking hell. Yeah, you have chip select. This one we don't use. No, this one we use. This one is the 3v3. Hold. Clock. And that copy thingy. Good, so let me try to find a way to connect to this Windows computer. Without sharing my screen. That would be nice. Connect, accept. I'm using some remote desktop crap, because there's no other way for me to get to that one. Okay, so we have that one on. Let me connect the USB there. Not sure how this goes in, like this. Good. And let's see that Neo programmer, will it read my chip? Detect. It's not working. Hey, Grandpa's bench. Hello, hello. It's actually, there's something wrong here. The Windows actually locked out. How is this even possible? So let's try again. Neo programmer. No, it's not seeing it. The adapter is not correct. I see not responding. Again. Yeah, I see not responding. This is, I hope, Well, there's also the possibility for the ROM to be actually defective. Yeah, it never happened on the iPhone. It happens quite often on MacBooks. So let me do some diode mode readings on this and see if we actually have any problem. 0.5, 0.5, 0.6, 0.5, 0.4. So everything seems fine. Why isn't it working? 0.4, 5, 5, 5, 5. My IC is not responding. I don't know if it makes any sense to actually check the wires again. And I'm really not in the mood to actually split the boards. There's no party, Grandpa's bench. It's actually only sadness. Because it doesn't work the way we want. That's freaking annoying. Good, so I did this properly, right? It's the second row and third row. Second row, third row. What the hell is going on? And why isn't it working? I'm gonna remove them. Okay, so I only have the 3v3 now connected and the ground. Let me clean this crap here. This is freaking annoying. Yeah, there's no short here. Alright, so let's go again. So the top one is the third one here is the purple, right? Top one is the purple. So we go like this. Purple comes on top. Good. Now, the other one is green. So is this one here. This one here is the green one. Good. Then we have the blue one on the lower left. It's the second one here. Okay, so I said lower left, blue. Good, and the other one is the orange one. Yeah, which should be the fourth here. Nothing wrong, man. Okay, let's go back to basics. Okay, that's connected. Let's fire up the programmer. Detect. The programmer is not connected, you freaking crap, motherfucker. Yeah, now the programmer is connected. Detect. It detected it. Yay, let's read it. Just for a test. I don't care about the read. I'm gonna write it. Good. It has read it. Perfect. So let me open the dump because I have what was written on that one. 1, 2, 3, 4. 1, 2, 3, 4. Yeah, let's have a look at it. It's all good. And I'm gonna erase, check erase, program verify. Go. Error erasing. It doesn't see the programmer anymore. This is annoying. Okay, let's go on again. This is not connected. My programmer sucks. Why is it doing this? Okay, connected. Detect. Chip is detected. Open. 1, 2, 3, 4. Go. And you couldn't see anything. Jesus. Error, so there's something wrong. Okay, let's try with Windows now that at least it's doing something. Okay, so it disconnected my programmer. That's some stuff that I really don't understand why it does this. Okay, we don't need that. We need, where is my Windows here? There's either something wrong with this memory, ROM thingy. Detect? No, when I click detect, I can hear the Windows machine doing bing bing, like disconnecting it. Yeah, and now it's locked. Okay, I'm going back here. Detect. No. Program disconnect. Yeah, if I put it on USB 3, it's not gonna work, so it's gonna detect it. Good. But it's not gonna do anything on USB 3. Go. Yeah, we're gonna get that sector 0 error. Okay, no problem. Disconnect. Okay, not connected. Let's do it again. It's connected. Yeah, and now it doesn't see my chip. I feel I'm gonna die. Did we miss something here? This is not touching that one. These all look good. It doesn't like the long wires. Maybe the wires are too long. I really don't understand. Okay, it says now connected. If I click detect, now it says erasing. Wait, I'm waiting. Yeah, I'm gonna force quit it. That's crap. That's a pile of crap. Okay, let's do this one and see if it's timed out. So there's something not good. Let's see like this. I need a better programmer. Yes, I was planning to actually buy a... I was actually planning to buy a new GPU graphics card, but I think I'm gonna buy a programmer. Failed to write. Found Win1 chip, so this is the chip. Okay, let's do... What was it? 1, 2, 3, 4. Let's do... minus. Nah. Maybe USB error my ass. Well, there's no other components on the 3v3 line because we've removed the ACE and there was nothing else, just some capacitors, right? So remember, there was nothing like that. What if we do sudo? No. Programmer initialization failed. I moved it to a different port. I don't know. I think this ROM is actually faulty, to be honest. Yeah. Well, what we can do is actually take a different board. Okay, let's try with another board. And let's see if it's my programmer crap or this one is crap. So this is a donor board, right? Let's work with it. Where's my microscope? Here. So we can actually do something. So I'm gonna remove this one. This is a good chip. Pum, 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 pum. I can't find my tweezers. Anyone knows where they are? I usually like the bent ones. This is a little stubborn. Good. It's out. Okay, I need to put this aside because that's a good chip. I need to keep it. And I'm gonna need to keep also the ROM for this one. So while this is hot, let me have a look here. I have a Legion. I did see a recent video, but in my case I don't even have caps right responsive. Yeah, that's definitely a CPU issue, not a GPU in my opinion. I think that's a CPU issue. Okay, so now that this programmer has sit a bit, let me try it again. I'm gonna connect it back to the USB. Yeah, let's see. Desktop. MS prog. So programmer is connected, it's recognizing my chip. I'm gonna open this one and I'm gonna do erase. Yeah, and now the programmer disconnected. Why is it doing this? Now it's connected again. Now it's disconnected again. No, it says not connected. I think my programmer is crap. Okay. So let's try with the other board. This one I already started at some point to get the chip off it. Let's do it side by side so it's easier for me just to put the wires back from where I desoldered them. Good, that is good. I need the ground. You don't see nothing. Good. So ground. Okay. Oh, I'm terribly upset. Good. This one. Good. This one will come here. Good. This one will come here. Good. So this is a donor board, right? We should read this one first. This is 1, 2, 3, 5. Okay. Desktop, good. Connected, detect. chip is not connected. Yeah, I definitely broke my I broke my programmer. I was doing something today with it. Let me see if I have another one. I had some EZP 2010, but I couldn't use it anymore. So let me see, EZP 2010. Does it work on Linux? No. No, because I can't install it in Windows anymore. Because it has some outdated drivers that do not install back in Windows unless you do some crazy stuff, putting it in some sort of a development mode, but not even then is working properly. So this is freaking insane, and definitely something wrong with the programmer, because I've done this a lot of times using this programmer. Chip is not connected. Okay, let's see again. Did I get it wrong? Let's see. Do I have the wrong screenshot? But I think we have something. Okay, so it's from here. Yeah, so let's do it again. Programmer is like this. Okay. I'm sorry. I'm just wasting your time now. But I'm gonna go crazy if I don't figure this out. Yeah, let me disconnect everything. It's either I have them wrongly connected or I'm an idiot. And that one is shorting out there, so something is not good. Let's see. So here it was shorting out with the ground, see? Yeah, you can see. Back to the microscope. Okay. So let's see again. Here we need some flux, here, good. Let me do it from scratch. And wonder how is this even possible. So this yellow one, this is obviously ground. Yellow one is ground. Well, you know, I told you I never had an iPhone with this chip actually defective, with the ROM defective. Okay, this is the third one, that's purple. It comes right here. Yeah, I need some solder on this. Okay, so this one comes here. Good. This is the orange, comes here lower right. Lower right. Good. Then we have this one, the red one goes to the cap. The red one comes here. I need some flux. Good. Then we have this one. That's the blue one, comes lower left here. Good. And the other one that just broke. So this one broke from here. Does the chip select? Yes, it did break. I need to clean it a bit. Good, so the chip select comes on the top right out of those four. Good. Now let's see if it works. If it doesn't, I'm gonna give up. And I'm freaking pissed. I don't wanna continue with it. Desktop. Okay, so this is connected. Detect. It detects it. Okay, I need to read this one because it's a donor board. So I'm gonna read it. Error reading block. No, definitely my programmer is fucked up. Okay, let's do from the terminal. Read. What is this? This is 1, 2, 3, 5. 1, 2, 3, 5. I don't need sudo for this one. No, error. Okay, I'm gonna leave it for a second. I'm gonna try the second port. Maybe also remove this from here. RT809H. What is that? Is that a programmer? I'm gonna stop buying Chinese scrap, so I'm gonna buy Revel Prog maybe. Yeah, maybe. Okay, let's connect this one here. I don't think it's gonna work. Flash from 1, 2, 3, 5. Okay, so at least it's reading it. Good. I'm gonna do another read with A. And the second one is no. So the second one is not reading it. So let's move it here. Well, it did do something. I do have two bins. Let's see, MD5 sum 1, 2, 3, 5 asterisk. They do have the same. Webin diff 1, 2, 3, 5 asterisk. Yeah, so they are identical. Yeah, so we might be okay. Let's see if I can delete this one. So if I do -E from erase, but I need to connect the programmer. Programmer connected. No. Failed. If we do IMS prog, okay, it's detecting it. It's okay, and I'm just gonna erase it. Let's see. Does it allow me to erase it? No. That's crap. Okay, I'm gonna try one more thing. I'm gonna try to actually have the wires a bit shorter. No, I don't have any chip in the socket. No, look. Let me turn on the lights. Yeah, so there's no chip here. I don't think it matters that this is closed or not. Obviously it's not. Can it be these wires are too long and it doesn't like it? I'm gonna cut them shorter. I really doubt this would be a problem, but whatever, let's do it. Because there's really not anything else. I'm not in the mood today to split the boards. I wanted to have a nice fast video. Yeah. So I'm not even gonna try with this one. So this is a donor board. I'm gonna put it aside. And I'm gonna come back to this one. Now the problem with this is that but they are empty. What do you mean it's empty? It's not empty. I have wires going to the chip, so from that deep thingy. But my time is running out. And this has a very, very strong thing on it that I have to use a knife to actually remove. Okay, maybe that's enough. No, the readings are not empty. I'm gonna show you. Don't worry. These chips are not written from the first address. But if we scroll down, you're gonna see that there's data there. Okay, so I hope there is some solder on this one that we could actually use to solder with. Okay, so let's do it again. Where's my picture? Okay, so the first one is the ground. Now with the shorter wires it's gonna be a bit more difficult. Yeah, I'm now back again on my original board. Okay, second wire, purple, comes up here. Good. Third wire, orange, comes lower right. Right here. Good. And then what is going on here? Okay. And then top right is going to top right. Green is going here. Oh boy, this is gonna be a bit difficult. Green is there. Okay, second one is blue, comes here. Good, and last one goes to the capacitor. Okay. Now let's see. I'm gonna take this back to the computer. Plug it in. So this is the board that we are working on. Yeah, connected, detect. It's not connecting. This is freaking. Yeah, the pin 8 has 3v3, so look. I'm putting the multimeter in voltage mode, right? I can't show you the programmer because it's here on the left. But the programmer is now connected, as you can see here. So it's connected to the computer, and if I measure the 3v3 that goes to the chip, yeah, here, 3v27. So it has that, but it says it doesn't detect the chip. This is crap. Chip is no. I did something wrong with it. I told you I did something today. I injected some voltage at some point. And I think I damaged it. Good. So I'm gonna stop here because I'm not in the mood anymore. This is freaking annoying. I need to get my other programmer or do something because I'm not gonna split the boards. Not in a chance. There's one wire that went rogue. Yeah, where is it from? Here. Yeah, but I'm definitely sure it broke now after I remove the programmer. Connected. Oh, it's detected now. This is freaking annoying. Okay, so this is my one that I want to actually erase, yeah? So I'm just gonna erase this one. He did erase it. Oh my god. Okay, so now I'm gonna read it. Yeah, it read it. It should be blank. And it is. Good. We're gonna open 1, 2, 3, 4. Yeah, and I'm gonna program it. Go. Oh my god, don't tell me it's gonna work when I was about to give up. Good. So now I'm gonna read it again. I don't want to do check erase, verify or whatever, so it doesn't die on me. Yeah, see, it's not blank. If I scroll down, there is data. Yeah, it's only a few of data, the rest is mostly blank. There's a bit here. Yeah, and then nothing. So a bit here and a bit here, and that's it. Good, but at least this time it wrote. Good, so we can actually go back and solder the chip, and maybe we're in luck. Okay, let's take the programmer out, and this ruined my day today. Okay, so let's clean this one. I'm just gonna wick it a bit so we don't leave all those there. Wick. Yeah, we're fine. And the rest, yeah, I'm gonna do the cosmetics later because I only have 15 more minutes tops. Okay, let's see which was the rebuilt chip. This one. Yeah, it's this one because the other one is the spare one from the other board, right? Yeah, that's the spare one. Good. I'm gonna add a bit of flux, not too much. This looks extremely nasty. Okay, and this comes like this. Yeah, I hope I'm not putting it wrong. Okay, let me just make sure the pin one is like that. Flex BV. Yeah, pin one is like that. Good. So let's solder this back. No, come on, just sit already. I think it's good. Good, so let's cool this off. My god, it's getting dark outside. Okay, let's do also some IPA because it's gonna cool off faster. If I find my brush, IPA all over. Is it factory? It is factory, yeah, but it's still, it is still too hot. Good. So let's do some cleaning here. I really don't like when I'm streaming because my desk gets really messy. And let's see, were we right, or maybe we also have a problem with the charging IC. Yeah, I'm just connecting the port, the charging port, and I'm connecting the battery. I don't care about the rest right now. Something is not staying here as it should. Okay. So these are connected. The moment of truth. Look here and look on the oscilloscope and let's see what's going on. Ah, sorry, I forgot something. So oh boy, the power supply was actually connected to the lab power supply. Good, so now we see also the USB. So we look here on the USB, we look on the oscilloscope. 5 volt, 15 volts, so it also negotiated. Yeah, 600 milliamps. Yay. So the phone is charging. Look there, the current is rising. Okay, let's put, yeah, and I heard the phone actually started. Good. Let me put a few of the screws back because I would like to actually put the screen and see if everything is good, although that screen you saw the condition, it was really bad. Afternoon, Paula. That was really bad, so this was almost ruining my day, but luckily in the end the freaking programmer decided to work. I'm so pissed off on that programmer. And I'm mostly using Linux, you know, and for Linux there's not much choice of a programmer. I think this was here. And from the good programmers there's Reballing, there's the T56. I don't know what name it has. Yeah, that's a good one. There's SVOD, but that's very expensive one. and yeah, and the chippers are these ones, that the CH341A. Yeah, but I would go with Revel Pro even if I have to use it on Windows, and that's it. Oh man, I did a bad thing. I need to remove everything. I have a problem. So let's see if we can. One of these flex cables remained under the board. Freaking cable. Let's see if I can actually remove it like this without unscrewing the 3000 screws there. And I always look for that tiny one, because it always happens to remain somewhere, or it's not there, but it should be, right? We should have two flexes there. Yeah, it's there. It's just very down. Okay, I've got it. I've got it now. See, this one, small one here. Yeah, it happens. I really wish it did not happen. I lost somewhere in the process the face camera. Did you see it falling off somewhere? It's here. Good. The front camera. Good, and let's put that cracked screen. Well, of course I'm not gonna put the back glass. I don't care about that. I can't see nothing really. I need to come here. I forgot to open the lights, and now I'm a bit lazy to go to the switch. Good, so everything is back together except the battery. Let me connect the battery. Battery connected. Okay, let's see. So let's plug it in. 5 volts, 15 volts directly. You see, it has negotiated. Yeah, and the phone is booting. Nice. Yeah, we have battery percentage there. Yeah, well, the touch works. Well, it's this crap, the crap screen, see? It works, but the crap screen is crap. Good. So I have there the battery percentage. If I connect it, it goes to 15 volts and everything is good. Yeah, I'm gonna turn it off because yeah, I don't think I can with this screen because the touch doesn't work everywhere. Yeah, it's pretty finicky. Yeah, but this is it. I was hoping we're actually gonna do two because I have another one. So I have a 16 Pro Max with the same sort of behavior, but the problem with that one is that it also has no it is reset, and on the reset screen it has only the serial number, so there's the baseband missing, or I don't know. That's very weird. The phone wasn't broken, and that's why I took it, because I found it extremely interesting. And yeah, I'm gonna do a video with it. I can't do more on this stream because it's 9 p.m. and I need to stop. Yeah, let me read a bit of the chat. Do you have a chip? No, about readings. Yeah, so those had data. Excellent job, well done. Thank you very much. I'm sorry, I don't know. I would have hoped this worked better. If that crap programmer worked better, then it would have been a faster one. Yeah, I did take the ACE from a donor board, yeah. Yeah, also the firmware. Yeah, so this is fixed. I'm gonna do the other one tomorrow maybe, if I have the time, and I'm gonna post a video that is very interesting. So I told you it has no AMAOEs, so it doesn't activate. I've never seen something like that. Also, it's not charging. Yeah, that's really weird. We'll see you. You will see it when I'm gonna post it. Yeah, so thank you very much for being here with me. I hope you enjoyed this one, and I hope we're gonna do more of this live series, although I don't really, it's a bit difficult for me. So during the week I cannot stream because of my job, and during the weekend I often do have a lot of chores to do, so it's a bit difficult. But yeah, this is it. Okay, so thank you very much for watching. Give me a like, subscribe if you didn't already, and we'll see you on the next live or on the next recorded